Before we proceed on our discussion, let me present to you our objectives. At the end of this lesson, you should be able to differentiate combination from permutation. List some important keywords to identify permutation question. List some important keywords to identify combination question. Identify permutation and combination questions without keywords. Let's begin. Permutations and combinations is a topic full of confusions. The biggest one is understanding the difference between the two. Should I solve it using permutation or combination? That is what we're going to discover in this video. In lesson number 1, we learned that permutations refers to the different possible arrangements of a set of objects. In lesson number 3, we learned that combinations refers to the number of ways of selecting from a set when the order is not important. Permutations is all about arrangements, and combinations is all about selection. In permutations, order matters. However, in combinations, order does not matter. Permutation of n objects taken r at a time can be illustrated in the form of p quantity n, r. The other common notations that may appear in different books are npr and p superscript n subscript r. On the other hand, combinations of n objects taken r at a time can be illustrated in the form of c quantity n, r. In other books, it is ncr or c superscript n subscript r. Most common mistakes that we may encounter in dealing permutations and combinations is applying selection in place of arrangement and vice versa. To clarify this confusion, let us discuss two simple cases. Question number 1. From 3 players A, B, and C, how many doubles team can be formed? Question number 2. From 3 letters A, B, and C, how many 2-letter words can be formed? Do both examples look the same to you? Well, the examples are not the same. Let's try to visualize two questions. Let's start with question number 1. Given 3 players, A, B, and C, we will form a double team, which means 2 players in one team. Let us say that we choose player A followed by player B. What if we change the order? We choose player B first, followed by player A. Do we have the same team? Yes, the team AB is the same as the team BA. How about on the second question? Given 3 letters A, B, and C, we will form a 2-letter words. Let's say we choose A first, followed by B. Does it make any difference if we choose letter B first, followed by letter A? Of course, the word AB is not the same as the word BA. Now, what makes the two questions different from each other? You are right. For the first one, the arrangements of the team members does not affect the team composition. Hence, the order of the players is not important. However, on the last one, the arrangement of the letters can give us 2 different words. Hence, the order is important. The first question can be solved using combination, while the second question can be solved using permutation. Now, let's try to solve the 2 given questions. First, identify the values of n and r in each problem. For number 1, we have a total of 3 players, so n is equal to 3. And we will form a double team which means we will select 2 players in each team, so R is equal to 2. On the second question, we have a total of 3 letters, so N is equal to 3, and we will form a 2-letter words, so R is equal to 2. Both questions have the same values of N and R, but we will solve question number 1 using combinations and question number 2 using permutations. In lesson 1 and 3, we already identified the formula for combinations and permutations. So, let's apply them in each problem. For combinations, we have combination of n comma r is equal to n factorial over quantity n minus r quantity factorial times r factorial. For permutations, we have permutation of n comma r is equal to n factorial over quantity n minus r quantity factorial. Let's solve each questions and compare the results. Let's substitute the values of n and r on the combinations formula. So we have combinations of 3, 2 is equal to 3 factorial over 3 minus 2 quantity factorial times 2 factorial. Next step, evaluate inside the parentheses. So we have 3 factorial over 1 factorial times 2 factorial, since 3 minus 2 is equal to 1. Expand the numerator and denominator, so we have 3 times 2 times 1 over 1 times 2 times 1. We can now cancel 2 times 1 on the numerator and denominator. 3 divided by 1 is equal to 3. Now, let us solve the second question. Substituting the value of n and r to the formula gives us permutation of 3, 2 is equal to 3 factorial over 3 minus 2 quantity factorial. Simplify, we have 3 factorial over 1 factorial, since 3 minus 2 is equal to 1. Expand the numerator and denominator, so we have 3 times 2 times 1 over 1, and cancel 1 on numerator and denominator. 3 times 2 is equal to 6. After solving the two questions using permutation and combinations with the same values of n and r, what can you infer? That's great! When it comes to combinations and permutations with the same values of n and r, combination is less than permutation. And I want you to remember that a permutation is an ordered combination. Visualizing each problems first will help you determine if the problem is about combination or permutation. Moreover, we also have the following keywords to identify a combination question. Some of these keywords are select, choose, pick, and combination. Whenever you read the question, look for these keywords, as these are the useful indicators that clearly tells us that the question is a combination. More so, the following keywords to identify a permutation questions are arrangements, ordered ways, unique, and permutation. Keep an eye on these keywords in a question. Whenever you get a question having one of these words, it will imply a permutation question. Let's have an activity. Determine the following statement or question if permutation or combination is involved. Are you ready? Great! Let's start with our first item. Arrangement of 10 books on a shelf. The keyword used is arrangement, which makes it permutation. This can be solved using permutation of 10, 10, since we have 10 books and we're going to arrange them all. Item number 2. Choosing 3 representatives for MTOP competition out of 30 students. The keyword used is choosing, So, we have a combination statement. This can be solved using combinations of 30, 3 since we have 30 students and we will choose 3. Item number 3. How many permutations of 4 different letters are there chosen from the 26 letters of the alphabet? In this question, we have two keywords. The word permutations and chosen appears in the question, which makes it obvious that this is an example of a permutation question. This can be solved using P of 26, 4 since we have 26 letters and we will choose 4. Number 4. Listing your 3 favorite desserts in order from a menu of 10. The keyword used in this statement is in order, which means order matters. Thus, we have an example of a permutation statement. To solve this, we have permutation of 10, 3. Since there are total of 10, and we will list 3 in order. Item number 5. Each signal that a certain ship can make is comprised of 3 different flags, hanging vertically in a particular order. How many unique signals can be made by using 4 different flags? The keyword used in the given problem is unique, which makes the problem a permutation question. To answer the problem, we will use permutation of 4, 3 since we have 4 different flags and we will hang 3 different flags. Item number 6. Picking a leader and 2 assistant leaders from a group of 10. The keyword used is picking, which makes it a combination statement. To solve this, we will use combination of 10, 1 times combination of 9, 2, since we have 10 members and we will pick 1 leader. Then, we will choose 2 assistant leaders out of 9 members left after picking a leader. Item number 7. Choosing 3 desserts from a menu of 10. The keywords used is choosing, which makes it combination. To solve this, we have combination of 10, 3, since we have a total of 10 and we will choose 3. Question number 8. There are 10 women and 15 men in an office. In how many ways a team of a man and a woman can be selected? In this item, the keyword is selected, which means that it is a combination question. It can be solved using combination of 10, 1 times combination of 15, 1. Since we have 10 women and we will select 1. We also have 15 men and we will select 1. Item number 9. There are 44 politicians at a gathering. They shake hands to everyone. How many handshakes were there? This item does not have any keywords to identify a permutation or combination question. So what we're going to do is to visualize the question to determine if it is permutation or combination question. This problem is all about handshakes. Imagine that a politician A shake hands to politician B. Does it make any difference if politician B shake hands to politician A? No, because that's just one handshake. Therefore, order does not matter when it comes to handshakes. Thus, this problem can be solved using combination, and that is combination of 44, 2 since we have 44 politicians and every handshakes, there are 2 people involved. Last item. A teacher wants to assign 4 different tasks to her 4 students. In how many possible ways can she do it? Again, this item does not have any keywords to identify a permutation or a combination question. So what we're going to do is to visualize the question to determine if it is permutation or a combination. This problem is all about different tasks. Since we have 4 students and 4 different tasks, let's say that student A assigned to the first task and student B is assigned to the second task. Does it make any difference if student A is assigned to the second task and student B is assigned to the first task? Yes, these are 2 different ways because order is important. Therefore, this problem is all about permutation and can be computed using P of 4, 4 since we have 4 different students with 4 different tasks.